Hello and welcome to Maths with Jacob. This lesson will focus on integration by parts. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. In previous videos, we introduced the concept of integration by doing examples involving simple functions. Here we look at a more involved process called integration by parts. Now I will just state the formula for you because I want to go straight into doing the examples. So the integration by parts formula is, if you have two functions, we'll call them u and dv, then the integral of u dv equals uv minus the integral of v du. That's the formula we use, and let's see how it operates. First example, we're asked to solve the following. The integral of 2x e to the x dx. The solution. The most important first step is to decide which part is u and which part is dv. So that's what we have to solve. We know that one of them has to be u and one of them has to be dv, but we're not sure. So here is a simple rule to help you decide which one is u and which one is dv. There are two functions multiplied together. One is 2x and the other is e to the x. That's quite easy to see. 2x and e to the x. Differentiate each function and see which function becomes simpler when it is differentiated. Let that function equal u. So let's differentiate 2x, that gives us 2. Let's differentiate e to the x, that gives us e to the x. Since the differential of 2x is simpler, we let u equals 2x and dv equals e to the x dx. So we have the integral of 2x e to the x dx equals uv minus the integral of v du. Now let's carry on the next slide. So repeating for ease of reference, that's the formula we just wrote down. Now, I have coloured u and dv in blue because that's what we have. We just need to find du and v. See, we have to find du and we have to find v, and then we're almost finished. So here's a little table to make it simple. Here is the u which we let equal 2x, so we've had that one, that's done. Here is the dv which is e to the x dx, we've done that one. Now, if u equals 2x, then when we differentiate 2x, we get 2 dx. So du is 2 dx. So we've just found that one now. See, that's why I put found. And v, now if dv is e to the x dx, if we integrate e to the x dx, we get e to the x, because we saw in earlier videos that the integral of e to the x dx was just e to the x. So we have found the two red values, du and v. Now we substitute everything into the formula, and we get this formula here, because u was 2x, v was e to the x. There's v again, see from there, e to the x, and du was 2 dx. Now all I've done here from that line to that line, I just took the 2 outside, which you're allowed to do that. That's just a constant, so we took it outside. So the integral of e to the x dx is just e to the x. So from that line to that line, all I've done is just perform this integration here, this integral. And here is our answer. The integral of 2x e to the x dx, which we were asked to find, is 2x e to the x minus 2e to the x plus c. Don't forget the constant because it is an indefinite integral. That's why we have the constant. Let's look at example 2. Solve the following. The integral of x cos x dx. Remember, this is the formula we had, so we repeat it here. Differentiate each function and see which function becomes simpler when it is differentiated. Let that function equal u. If we differentiate x, we get 1. If we differentiate cos x, we get minus sin x. Since the differential of x is simpler, we let u equals x, hence dv equals cos x dx. So we continue on the next page. So there's u, and there's dv. Now here's our table again. We have u and dv, we found those. We just need to find du and v. So there's u, there's dv. Now if u is x, that means du has to be 1 dx, because when we differentiate x we get 1. If dv is cos x dx, if we integrate cos x, that gives us sin x. So now we have everything we need. We had those two that were in blue. We've just found the two red ones. After substituting the above values into the formula, we have the information to the right. So we've just substituted everything into the formula, into that formula here. Now a little bit of simplification here. We know that the integral of sin x is minus cos x. So when I integrate sin x, I get minus cos x. Now from here to here, minus by minus gives you plus. So in other words, the integral of x cos x dx, there is the answer, and don't forget the constant because of the indefinite integral. Sorry, because of the, that's right, the indefinite integral. See, because we have no limits. See, there are no limits here, so it's an indefinite integral, so we have to have the constant. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? Keep in shape. How good is that? Here are the answers to the quick quiz, and the video is at your disposal.